GMAT all day.
In the last video, we introduced ourselves to our rules for what we can and can't do regarding inequalities and manipulating inequalities. So now let's take a look at some of those rules in the context of actual GMAT questions. And I think I said before that most of the time inequalities are really used just to test other concepts. And so you still need to keep in mind all your algebra rules and all of your exponent rules and all your number property rules, and then incorporate those with your inequality specific rules. And so this question here just says, is x greater than x squared? So inequalities, we need to talk about what we can and can't do. So let's talk about what we can't do first. And they're always trying to bait you to do the thing that you can't do, especially with inequalities. And so what most people are going to want to do here is divide each side by x. And when you do that, you get x divided by x is 1. Square divided by x is just x. And so that leaves us with just x is less than 1. And so remember, this is our question here that we are manipulating. We're rephrasing our question, not giving information. And so if we were to do this, if we were to divide each side by x, we would then rephrase our question as, is x less than 1? We would then look at the first statement and say, oh, that is directly answering our question. That is sufficient. Then we would go like there, thinking that was easy, when in reality, we fell for their trap, because you will not be doing that. You will not divide each side by x, because you watched that last video and you know you cannot divide by a variable with an inequality unless you know two things. You need to know that that variable is not equal to 0, which we do not know in this case. And we also do not know the sign of that variable. So we need to know both of those things. Now, does that mean that it is hopeless? We cannot do anything with to simplify our question? That is also not true. So what can we do? And you should know from the last video that you can always add or subtract from each side of an inequality. And so if I want to get all my x's on the same side by subtracting x squared from each side, that would just give me x minus x squared. I should say, I could then rewrite my question as, is x minus x squared greater than 0? And then if I wanted to, I can factor out an x here. There is nothing wrong with that. Usually prefer to do that because when you factor something, you turn a addition or subtraction problem into a multiplication problem, which I think oftentimes tells you a lot more. And so if I were to factor out an x, I would leave me with x times 1 minus x. So is x times 1 minus x greater than 0? So I want to figure out, what is this telling me about x ultimately? Because that, I think, is the easiest way to rephrase the question. So for this to be true, for x times 1 minus x to be greater than 0, either x and 1 minus x have to both be positive, or they both have to be negative. They have to have the same sign. So these are the only two ways x times 1 minus x could be greater than 0. And then try to say, well, what are each of these scenarios telling me about x? So for 1 minus x to be positive, in this case, so x is positive, and for 1 minus x to be positive, x has to be between 0 and 1. Then in this case, x and 1 minus x are both a negative. So in this case, x has to be greater than 1. But that is in fact not possible, because both x and 1 minus x have to be negative. And so here, x cannot be greater than 1 here, and then negative over here. So this is not a possible scenario. And that makes a problem simpler, because I only need to worry about this scenario here where x and 1 minus x are both positive. And therefore, really, I can rephrase my entire question as, is x between 0 and 1? Once I do that, I'm not thinking at all about exponents or the question as given. I just need to know, is x between 0 and 1? And so statement 1, which says x is less than 1, does not tell us if it is in fact greater than 0, which we also need to know. And so this is insufficient. And we'd already be noting that this is different than what we had selected, or what you would have selected if you fell for their trap. That's a good thing. Statement 2 tells us x cubed is greater than 0. So here we just need to know the properties of our even and odd exponents. We have an odd exponent here, 3, which means that the value of our overall exponent should retain the sign of the base. Because when you have an odd exponent, the overall value retains the sign of the base. And so in this case, if x cubed is greater than 0, that means x must be greater than 0. And so knowing that x is greater than 0 is still not sufficient to answer our question. We need to know if it's between 0 and 1, so this is still insufficient. But now, looking at them together doesn't require much work at all. So statement 1 tells us x is greater than 0. Statement 2 tells us x is less than 1. Question is asking, is x between 0 and 1? So together, this directly answers our question C. Let's do another question testing our inequality rules. Here we have, is AB greater than 1? In this case, now, really don't think there's much we can do with our question. We're not given any information in our prompt. We only have a question. And so let's go to the statements. Statement 1 says ABA is greater than A. So again, what are they trying to get you to do? They're trying to get you to divide each side by A. And if you were to do that, you would then say AB is greater than 1. That directly answers our question. This is sufficient. If you were then to do the same thing in the second statement, divide each side by B, you would also get AB is greater than 1. Then you would select the D as your answer, and you would say that was an easy question, even though you completely blew it. So we know that you cannot divide each side by A here. So we do know A cannot be equal to 0, because this statement here is given information. If A were equal to 0, the left side would not be greater than the right side. So we do know A cannot be equal to 0, but we do not know the sign of A. Therefore, we cannot divide by it. Now, we can do the same thing we did before. We can still subtract A from each side. So this is telling us ABA minus A is greater than 0. And we can factor out an A if we wanted to. Get A times AB minus 1 is greater than 0. So then I want to figure out, what is this telling me about AB? Because that's what the question's asking about. So again, there's only two ways A times AB minus 1 can be greater than 0. Either both positive or they're both negative. If A and AB minus 1 are both positive, what is that telling about AB? So here this means A is positive. Then based on the second part here, AB must be greater than 1. What about here? So now we know A is negative. If AB minus 1 must also be negative, AB must be less than 1. So even though in each of these cases we know something about A, we don't know anything about B. Because, for example, down here, A must be negative, AB must be less than 1, but B could still be positive or negative. As though AB can be greater than 1 or less than 1. So statement 1 is insufficient. Now, statement 2 looks pretty similar to statement 1. And the reason I just mentioned that is just in terms of GMAT strategy. If I were short on time or if I were running out of time and had to guess, I would not guess B as my answer here. Because it looks to me like if statement 1 was not sufficient, statement 2 looks very similar. And so it's probably true that statement 2 alone would not be sufficient. So we don't need to go through again all the things we can't do. Let's just get to what we can do. I can subtract a B from each side. EAB minus B is greater than 0. Factor out of B. And again, so it's telling me B times AB minus 1 is greater than 0. So either both of those things are positive or they're both negative. So in this case, I know B is positive. And AB must be greater than 1. Here I know B is a negative. And AB is less than 1. But it is the same thing as the previous statement. AB can be both greater than 1 or less than 1. And so this is definitely insufficient. So now, when I'm looking at my two statements together, it looks like I can still have, so AB greater than 1. So I can still have AB greater than 1. And when that's true, A is positive and B is positive. I can have AB be less than 1. So when AB is less than 1, A is negative and B is So can that? We have this scenario, and we can still have this scenario, right? Because even though, so if A is negative and B is negative, AB will be positive. It can still be less than 1. So we can still have this scenario here, and therefore AB can still be greater than 1 or less than 1. And therefore, looking at our statements together doesn't really contribute much new information. AB can still be greater or less than 1. And E is our answer here. In the next videos, we will look at some more inequality